Let's take a look at this momentum problem. Here's the question. You are to find the speed of a 0.9 kilogram puck. This puck is called the incident puck, and that means it's the one that is moving in to have a collision. It's the incident puck, and you are to find its speed. There's a collision between that puck and another puck that's 0.7 kilograms, and that is called an oblique collision, which means it hits it just at the side, not head on. So the incident puck, as you see, goes off at an angle of 21 degrees. The other puck, the darker one or the target one, goes off at 43.7 degrees. You are to find the speed, and what happens is you are given what's called a strobe photo. And so between flashes is 0.5 seconds. So that little interval that is shown there, where the arrow is 0.5 seconds, as is every other interval. That's what the question looks like. Now here's what you need to do. You need, first of all, to find the velocity from that diagram. Velocity, as you know, is distance over time, so you take the distance between the little flashes. The time is given. Once you know the velocity, you will find the momentum of each one of those pucks after the collision, and then you will simplify the drawing by turning them into just vectors and make it into a very simple drawing. So let's look at the picture again, and you do those steps. If you can hit pause and try to work that out. You want the momentum of each one of those in a simplified drawing. So let's start by finding the velocity then of the incident puck. There it is. Velocity is distance over time, and the distance is shown on the diagram, and the distance is 0.03. The time is 0.5, and therefore that particular velocity will be 0.06 meters per second. Next we look at, and by the way, the momentum then is found by taking that mass, the 0.9 kilograms, and multiplying by that velocity. That will tell you the momentum of that particular puck. Now let's look at the target one, the dark one. That velocity is the distance divided by the time. The distance is 0.02 and the time is 0.5. So when you work that one out, you will get 0.04, and again, meters per second. And as before, you find the momentum by multiplying that mass times that velocity. There's the mass. Now, to simplify the drawing, we draw vectors to represent each of those momentums. The incident one comes in, there's the collision, there is the momentum of the incident puck, there's the momentum of the target puck. If you worked it out, the momentum would be 0.054 kilogram meter per second, and for the other one, you would get 0.028 kilogram meter per second. You now know each of those vectors. Your next step is to add them head to tail. And that'll tell you the total momentum. There they are, head to tail. Now that one was there, and we moved it up so that you have the head to tail looking like that. We also need to find angles at this point, and so let's just go back and remember this one here was 21 degrees, so that's an easy one to find. But when we bring the other one up, what is the angle? So that was angle, I'm going to call it theta. It's 43.7. Theta is easier to write down quickly. And therefore, if that's theta, this is theta right here. And I think this is called opposite interior. This one here also would be theta. So that angle in the triangle that we will make will be 43.7. So let's take a look at this again. We know that that angle is 21 degrees. We know the other angle is 43.7. But what about the larger angle? Well, it's pretty easy. The sum of the angles in a triangle comes to 180. Therefore, it's very simple to say 180 minus 21 minus 43.7 will give us the angle 115.3. We now know that larger angle. So now let's take a look at our diagram and find out how we'll find the total momentum afterwards. There it is in red. We've added the vectors head to tail, and that red arrow represents now the total momentum after the collision. That's the momentum. Now we can find it because we know all the angles. You can use adding it by components, or we will use the law of the cosines. Now some people get confused with this, so let's take a look at what each variable represents. That would be C, and there's angle C. Always the long one would be C. There would be A, and angle A is right opposite it. We need B. This would be side B, and opposite it would be angle B. Then you subtract 2AB. It's easy to calculate now. And then cos C would be the cos of 115.3, that angle that we worked out. So, put the numbers through and see what you get. Here's how I did it. C squared is equal to, obviously, 0.054 squared plus the B is 0.028, and remember to square it. Then we subtract 2AB, 2 times 0.054 times 0.028 times, remember, the cosine of that angle, the larger one there, which is C, 115.3. Now when you work this out, don't forget to take the square root. That's a common error that people forget. So C equals what? The answer is 0.0706564, and don't worry about significant figures at this moment. That represents the total momentum after the collision, which is also the total momentum before the collision. Now our problem, if you remember, was to find the speed of that incident particle. So we know that mass times the velocity of that particle will equal the total momentum, which is right there, the same one we calculated, that long number. So the velocity that we need then, or the speed in this case, will simply be that momentum divided by the mass of that incident puck. So when you work that out, you take that long number, put it in for P, take the 0.9 kilograms for the mass, and you will find that the velocity in our final answer is 0.079 meters per second.